So what I want to go over is the one example where we had a couple things I want to go over, but we have the limit as x approaches 0 of the square root of 4 minus x, and that's equal to 2. So there's a little subtle trick with this one, and it's similar to the example where we had a value for epsilon. So what we're going to do with this limit, what we want to show is for any epsilon greater than 0, there's a delta greater than 0 such that if we have x minus, in this case we're approaching 0, but we'll say x minus c. C is going to be 0 in this case. When this is less than delta, then the distance between f of x and the limit is less than epsilon. And again, epsilon is just an arbitrarily small number. So we're going to start this out like we did in the review. So the steps we're going to follow are the same in the review, except we're going to use a little trick. It's going to get us out of a little conundrum. And again, it's similar to a trick we used when we had that other example where epsilon was 0.1. So we can break this down like this. And then we can add 2 to both sides. And we can square everything here. And then we could subtract 4 from everything. And so next what we can do, multiply through by -1, and that's going to cause these to flip around. So we're going to get 4 minus 2 minus epsilon squared greater than x greater than 4 minus 2 plus epsilon squared. Let's double check the math there, looks good. And then we can expand on this. I'm going to rewrite it so it's a more familiar form, actually. We'll do it like this. All right. So now we expand these. We'll get 4 minus, this will be 4 plus 4 epsilon plus epsilon squared less than x less than 4 minus for minus 4 epsilon plus epsilon squared. And if we distribute the minus signs, what we're going to get, we'll get the 4's to cancel here. So negative 4 and 4 will be 0. We'll have minus 4 epsilon minus epsilon squared x. The 4, the minus the 4 will cancel. This will also distribute the 4 epsilon. This will distribute to minus epsilon squared. And this is where we sort of came to a halt last time. Now, what can we do at this point? Well, this is where we can draw our x-axis and take a look at what's going on here. So here's 4 epsilon. Here's minus 4 epsilon. Now, if we take minus 4 epsilon and subtract an epsilon squared, that's going to put us here. Remember, epsilon is a tiny positive number. Then, if we take negative 4 epsilon and we subtract epsilon squared, that's going to put us over here. So the interval we get for x, if we have a situation like this, then x is going to be in this interval. So our x is located somewhere in here between negative 4 epsilon minus epsilon squared and 4 epsilon minus epsilon squared. Now, that being the case, what we can do is make this interval even smaller. Now remember, we want x to get close to 0. That's sort of the key value here. We want x to go to 0. So we can make this even tighter. We can squeeze x between this point on the x-axis and this one here. Now this is one that we started with. This is one that's still within this interval, but it's even closer to 0 than minus 4 epsilon minus epsilon squared. Take minus 4 epsilon, instead of subtracting epsilon squared, take minus 4 epsilon and add a little positive number to a negative number. It's going to bring you closer to 0. So we're going to try to put x between these values. So what is that going to look like? Well, we're just going to require that x be closer to 0 is what we're doing. So what we're going to have, minus 4 epsilon minus epsilon squared is less than minus 4 epsilon plus epsilon squared, which is less than x, which is less than 4 epsilon minus epsilon squared. Now there's a little algebra trick I'm kind of looking at here. So we're going to focus on this now. The algebra trick is if we factor out a minus here, what we're going to get is this. Now, the reason this helps is we're using a property of absolute values. And the property says this. If absolute value of x is less than c, then we can rewrite this as negative c less than x less than c. Likewise, if we have this, we can rewrite this as that. Well, in this case, this is our c, this is minus c. So a little trick here is kind of looking ahead to kind of create this kind of a situation. So this means we can rewrite this as the absolute value of x less than 4 epsilon minus epsilon squared. Or this could be x minus 0 less than 4 epsilon minus epsilon squared. That is going to be c, and this must be delta. So a little, you got to do some tricks here to kind of get this one out. But that is one way you could do this. And for the final answer, for any epsilon greater than 0, there's delta equal to 4 epsilon minus epsilon squared, such that when x minus c, which is 0, is less than delta, then f of x minus the limit 2 is less than epsilon. And that's going to be it. So if you have any questions about this, let me know.